Alright, today we are going to start the third and final portion of our quadratics unit, and this is kind of where we bring all of these ideas together and talk about how we would solve a quadratic equation. There are several different methods that we're going to learn for how to solve. Sometimes you have a choice, so sometimes you can kind of pick and choose that in this problem, I think I'm going to do this method because I like this method best, and sometimes more than one method will work. Sometimes it's really just one method that's going to work, so it's important that we do learn all of the methods and not just kind of pick one that's our favorite and say that we're going to go with that one every time, because they don't all work every time. Solving by factoring happens to be kind of my favorite way, but it's one that doesn't work all the time. So when it works, I like to do it, but it can't be the only thing that I do. So to solve by factoring, what we're going to do is first put our equation into standard form, which means we need everything on one side of the equal sign and just a zero on the other side. So if there's stuff on both sides, we have to add or subtract it over so that everything ends up on the same side. This one's already ready to go for that. Then what we would do is check to see if it's factorable. If you're told to solve by factoring, it will be factorable. I'm not going to trick you in that way. So what we want to do is look for how to factor it, remembering that if something divides out of every term, that should be the first thing we check for. And we want to check for those special forms as well. So we'll go ahead and factor this one. There's nothing that divides out of every term, so then when we factor, we're thinking about what multiplies to make negative 18 that we can add to make a 3. So for 18, I could do 1 and 18, 2 and 9, 3 and 6. So how can I make a positive 3 out of that?
6 and 9.
A 6 and a negative 3 will give me a positive 3. So my factors would then be x minus 3 and x plus 6. Now the idea of solving by factoring uses the fact that if I'm multiplying two things and it equals 0, either one or both of those things has to be 0. That's the only way to multiply and get 0, is if one of the two pieces is 0. So what we're going to do then, for our last step to solve this, is say, perhaps then, the x minus 3 is equal to 0. Then what would x be? 3. Or, perhaps, the x plus 6 is equal to 0. Then what would x be? Negative 6. And we get two solutions. A quadratic can have up to two solutions. So we studied linears before, and linears could only have one solution, but quadratics can have up to two solutions. Okay? So we get everything on one side set equal to 0, factor it, and then set each of the factors or each of the parentheses equal to 0 and solve them. Alright, so does something divide out of all of these terms? Are all of these numbers divisible by the same thing? No. So 9 and 12 share a 3, 12 and 4 share a 2, but 9 and 4, they don't share anything. So I can't divide everything by a certain number. So now I need to factor it. With a number in front of the x squared, that should be a big hint to you that this is going to be a special form, because we haven't talked about how to factor things that have a number in front of the x squared yet, unless it's a special form. So for our special form that had 3 terms, we had something squared. We need all perfect squares as our first and our last, so what multiplies by itself to be 9x squared?
3x.
3x. What multiplies by itself to make 4? 2. And then what sign would I use? The minus. Now we want to confirm that this is actually a special form. And remember the way we do that is we multiply these two numbers together. 3 times 2 is 6. And we double that and we get 12. And that should be your middle number. That confirms the special form. Okay, so if this is 3x minus 2 squared, that's really like 3x minus 2 times 3x minus 2. There's only one parentheses here to set equal to 0. So we're going to say 3x minus 2 equals 0, and solve for x. So add 2, and 3x would be equal to 2, and x would be equal to 2/3. So there's only one solution for this quadratic. So quadratics can have up to two solutions, but they don't always have two solutions.
Okay, why did you get rid of the parentheses and the square again?
Squared really just means times itself. So another way of writing this would be to say 3x minus 2 times 3x minus 2 equals 0. And then our last step was that we would set each parentheses equal to 0. But they're the same thing. So we really just set it equal to 0 once.
Wait, I'm confused as how you got 3x minus 2 squared.
That's our special factoring form where we look for perfect squares. So the perfect square of 9x squared is 3x. The perfect square root of 4 is 2. And then we use the sign in the middle.
Gotcha.
So what are our answers are finding x?
Yep, our answers are solving for x.
This first one, so our answers were 3 and -6.
Yep, so it's possible to have 2 answers for x.
So that, we don't do anything with that square.
No, because squared really just means times itself. So that just lets us know that we really have 2 sets of that same answer. Alright, this one has stuff on both sides. So our first step is to get everything on one side. So I'm going to do that by subtracting 3x from both sides and adding 5 on both sides. It doesn't matter whether you move everything to the left or to the right of the equation. I usually do it in such a way that whatever my x squared is will be positive. So since it was already positive over there on the left, I moved everything to be with it. If it was negative, then maybe I would move it all over to the other side. But it doesn't really matter which side you move stuff to. Now we want to look if there's anything that divides evenly out of every term. 2 divides evenly out of every term. So we learned when that happens, we can make one big parentheses and just divide each number by 2 all the way through. Now we want to factor what's inside those parentheses by saying, what can I multiply to get 25? So that'd either be 1 and 25 or 5 and 5. That I can make a negative 10 out of. Negative 5 and negative 5 would make a negative 10. So x minus 5 and x minus 5. Now this problem has 3 things multiplied together. So this one's like a times b times c equals 0, but still one of those things has to equal 0. That's the only way to multiply stuff and get 0 is if at least one of those things is 0. So the first thing is 2, but 2 can't be 0, so there's no solution from that. Then the next one is x minus 5 equals 0, and the solution to that is 5. And that's the other one as well, and you don't have to do it again because you're going to get exactly the same answer. So this one only has one solution, just 5. So when you pull a number outside of the parentheses, it will not affect your answer in any way. A lot of students want to solve the parentheses and get an answer of like x equals 5 and then multiply that answer by 2. That 2 in the front will have no effect on your final answer because 2 can't equal 0. So no solutions are coming from that answer. Okay? Alright, this one has stuff on both sides, so I have to start by getting everything to the same side. Again, it doesn't matter whether you move everything to the left or to the right, but I like to try to keep stuff positive. So I'm going to subtract the 3x and add a 6 so that my x squared is still positive. So we get x squared minus 3x minus 4. Nothing divides evenly out of all of these, so then I set up my parentheses and I want to factor. I want to look for what multiplies to make negative 4 that I can add to make negative 3. So what would that be? Negative 4 and a positive 1 would make a negative 3. Then if those are my factors, I set them each individually equal to 0. Because if multiplied together they equal 0, one of them must equal 0. So x could be negative 1, or x could be 4.
Why do you get negative 1?
Because we're setting it equal to 0 and solving. So I would subtract 1 from each side, which give me a negative 1 for x.
What? Doesn't make sense.
If I'm solving x plus 1 equals 0, I would solve that by subtracting 1 from each side. So that gives me a negative 1.
I see. Okay.
Right? So we set it equal to 0 if it's not set equal to 0. We factor and then set each factor equal to 0 and solve those individual equations. You can get up to 2 solutions. This one has stuff on both sides. I want to try to move it in such a way to keep my x squareds positive, so I'm going to add an x squared to both sides, which then means I'm also going to subtract a 23x from both sides. We get 3x squared minus 33x equals 0. What divides evenly out of those terms? 3 and x. They both have a factor of 3. They also both have an x. So if I divide both the numbers by 3, I get 1 and 11. If I take an x out of both of them, I've got an x and no x's left. Now we want to set each factor equal to 0. So that means I'm going to set 3x equal to 0, and I'm going to set x minus 11 equal to 0. Everything that's multiplied in the problem needs to be set equal to 0. So if 3x equals 0, what does x equal? 0. So I would divide both sides by 3 and x equals 0. And if x minus 11 equals 0, what does x equal? 11, because I would add 11 to both sides and get x is 11. So this one has 2 solutions, 0 and 11. Okay, so when you pull something out, you want to try to set it equal to 0. If it's just a number can equal 0. But this one had a number and an x, so that could be 0.
So you put whatever's outside the parentheses equals 0 and whatever's inside.
Yep. Everything that's multiplied in the problem gets set equal to 0. This one has everything on the same side already, so it's ready to be factored. So we want to make a list of stuff that multiplies to be a negative 8. So 1 and 8, 2 and 4. That I can in some way add to make a negative 2. So what would that be?
Wait.
2.
Negative 4 and positive 2. And we set each factor, each thing that's multiplied together equal to 0. And solve them individually. So in the first one I would subtract 2 and get x equals negative 2. Second one I would add 4 and I would get x equals positive 4. Questions? This one has stuff on both sides. So I'm going to subtract 1 from both sides to get it set equal to 0. This only has 2 terms, which is a big hint that it should probably be either a special form or have something that's divisible out of both of them. There's nothing that's divisible out of both of them, so then this should be a special form. Our special forms deal with perfect squares, so what times itself is 4x squared?
2x.
And what times itself is 1? And what do I do with my signs? A plus and a minus. So that they multiply to make a negative 1 if I look at the lasts, and my outsides and insides, if I would FOIL this back out, would end up being 0. Okay, so in a special form where you just have 2 things, you do the square roots of each of them with a plus and with a minus.
Why couldn't we do, once you have 2x, say, can you do like 2x equals 1 and then x equals half?
No,
Or
you
why
you can't just take a square root of one part of it. We will talk about, yes, technically that's correct. You're losing an answer when you do it that way. We'll talk about, that's called a method, that's called solving by taking square roots, and we'll talk about that method. But today we're going to solve it by factoring. Something like that would work, but you're losing an answer when you use that. So we're going to set each of these equal to 0, and then solve them individually. So the first one I would add 1, and divide by 2, and I get that answer of x equals a half. That Harrison just said should be an answer. And then I solve the other one by subtracting 1 from both sides, and dividing by 2, and I get x equals negative a half. Should also be an answer.
How did you get the 2x minus 1 and 2x plus 1?
That's our factoring of our special form, that we look for perfect squares. So the square root of 4x squared is 2x, and the square root of 1 is 1. When we just have those two terms, we do the plus and the minus to cancel out the insides.
For this one, like before, when it had when it would have been the same thing, just when the squared outside. For this, do we have to write it twice? Or can we just write the answer once, since it's the exact same thing?
It's not the exact same, because it's a plus and a minus, so we ended up with 2 different answers. So in the other one, when they were exactly the same, we could just do it once, but here there's actually that difference in it. This one has stuff on both sides, so I'm going to add the 49 over. And then I want to solve. I want to look for what multiplies to make 49. That adds to make a negative 14. So what would that be?
X minus 7, x minus 7.
Both minus 7. So we give us a positive 49 and a negative 14. Since they are exactly the same, we really only need to solve the problem once, because we would get the same answer either way, that x equals 7. So this one only has one solution. So it's possible to get 2 solutions or 1 solution. It's actually possible to get no solutions as well, but we're not going to encounter that today. Questions? In this one, I'm going to get everything on one side. I'm going to do that by subtracting the 30x. You only have 2 terms. It's a big hint that either it's a special form or something is in common to every term. So what is in common to every term here? 5 and an x. So I divide the numbers by 5, I get a 1 and a 6. If I take an x out of each of them, I get an x and no more x's. Then we set each of those factors equal to 0. So 5x equals 0 or x minus 6 equals 0. Solving the first one, I would divide by 5. And solving the other one, I add 6 and get x equals 6. And just like with linear equations, you can always check your answer by plugging it back in. So you could take an x equals 0 and plug it back into the original equation and say, does that work? Do I get something true? If I do, if I plug it in, I get 0 equals 0. So that's good. If I take the 6 and I plug it back into the original equation, I get 180 equals 180. So that's a good thing. So you can always check your answers by taking them back to the beginning and plugging them in and make sure that it results in a true statement. Questions? All right, we are going back to section 5.2 for our homework tonight.
5.2, wow.